Hello, so today I'm going to be going over integration by parts, specifically the DI method, where you just write D and I when you do the questions. It's also known as the tabular method, but I would recommend this method for mainly visual learners because there is this formula here that you can also use, but to be honest, I have no idea how it works. And I always just use this method every time, and it works quite well. So for example, say I had this question here where you have to find the integral of x cos x. This kind of looks like products rule, right, from differentiation, but there's an integral sign at the front. So the reason why it's called by parts is because you do them separately in parts. So the two parts here, it should be fairly obvious what parts there are. So here there's an x and a cos x. So to start, all I'm going to do is just write d and write I, and these stand for differentiation and integration. So the next step is we have to put these two parts into these two sections here, right? Oh, that looks like a smiley face. And I'm pretty sure it's never going to ask you for more than two parts here. So this method should always work. But first I'm just going to go straight into a question and then I'm going to explain it afterwards. So what I would do is I'd put x here and cos x here, and then I would differentiate x, which is just 1, and then I'm going to integrate cos x, which is sine x, and then I'm going to do it again. So 1 becomes 0 and sine x goes to negative cos x. Then an important thing to note here is that there should be a plus, minus, plus, and it keeps on going down. But yeah, it alternates between plus and minus in the D column. So now all you have to do is multiply the first one here with the second one here. So like this, and then you just keep on going down like that. So the reason why I stopped at 0 is because anything multiplied by 0 is just always going to be 0. So there's no point in continuing to go down, right? So this ends up being x sine x plus cos x. The reason why it's plus cos x is because this is a minus 1 here because of the negatives and positives. So yeah, that is just the final answer for this question, but make sure you don't forget the plus c at the end. But yeah, that's it. So something that you always want to remember is that you always take just x values like this and you put it in the D column, because then that always goes to 0, right? So you always end up with this example here. But then say for example that it was like sine x cos x and it told you to integrate this, neither of these would go to 0, right? So there's an extra step you can do and I'll show that in a second. Okay, so this next example is slightly more complicated, but it's not too bad. But one thing that you always have to notice is that even though it's just one value here, there's not really any other integration techniques you can use to evaluate this. So what you can do is you can just split this into ln x and 1. So now if we just use our DI method from before, now it may be tempting to put the 1 into the differentiation column, but then if you think about it, that would mean that the ln x would be in the integration column, right? Which is not really what we want, because then you just have to integrate ln x, which is the whole point of the question anyways. So what we're going to do is put the ln x into the differentiation column and then the 1 here. So then if I differentiate this becomes 1 over x, right? And this becomes x. You don't need to worry about plus c's or anything whilst doing this. You only need to add that at the end, or you don't even have to in this example because it's a definite integral. So now we're left with this, right? Make sure you don't forget the pluses and minuses. So I'll add those there. So now you may have spotted that these columns are just going to continue going forever, right? This would keep on getting smaller and this would keep on getting bigger. But if I start off by just using the method from before, where you multiply this, then that leaves you with x ln x, right? But then what do I do here? So because there's nothing else I can go to here, because it's just going to keep on going forever, one thing you can do is multiply these two together. But then because we haven't actually done this properly by multiplying it by the next term, we have to put an integral sign right here. So you end up with minus, because the minus is still there, minus the integral of 1 over x times x, which is just 1. So you end up with this. So then the correct answer is just x ln x minus x. And then because this is definite, I'm going to add the bounds 2 and 1. And then you can just substitute these in from there and you're going to get 2 ln 2 minus 1. So that may be a bit confusing to start with, but if you practice this, it gets a lot easier in my opinion, and it's a lot easier to remember than just formulas. So I'm just going to move on to some more questions now. Okay, so I know how I said that they aren't going to give you more than 2 parts. So one thing to always note is that if it looks like it's more than 2, then you're probably just wrong, because you have to group them together. So like this would be 1 here, and the other one is just x. So because it's just x again, I can use the main strategy of putting x in the derivatives and sec x tan x in the integral side. So then this just goes to 1, this goes to sec x, and this goes to 0, and then sec x goes to ln sec x tan x. And these are both in the formula book, by the way, so you don't need to remember these. But anyways, if I do my plus minuses like that and then multiply, it's going to be x sec x minus ln sec x tan x plus c. There we go, that's it. So moving on to the next question. Okay, so next question, I thought it would be fun to do one with e, because e is really fun to integrate, and you'll see why in a second. So if I just put the x squared and e to the minus x in my columns, I'm going to start by doing all the differentiation on this side. This is going to go to 2x, this is going to go to 2, this is going to go to 0, and then this just goes to minus e to the minus x. This just becomes e to the minus x, and this is minus e to the minus x again. So it's just a nice alternating pattern. And then I'm going to do my multiplication, but make sure you don't forget about the positives and negatives. So this is going to be minus x squared e to the minus x minus 2x e to the minus x minus 2 e to the minus x plus c. And then just for an extra step, you can factor out minus e to the minus x here, and then you get a quadratic here, and then don't forget the plus c at the end. So by now you should be getting a general feel for how this works, but there is one more thing I can show you with by parts, where both of these columns actually go on infinitely, and they don't multiply together to make anything. So that's a really rare question they'll ask, but it's important to be aware of it. Okay, so I found an example here where both of them would go on infinitely, because like it should be fairly obvious from what you have here. Like these both don't really work with each other. So what I'm going to do is, if I just put e to the x here and sin x here, I'm just going to do a few and you can see what happens. I'm pretty sure this will also work if you do the other way around, but this makes the most sense. So if I just do e to the x, this becomes minus cos x, and this becomes e to the x again, and this is minus sin x. So sin x and minus sin x are quite similar, right? Like the only difference is there's a negative sign in front of this. So I'm going to stop here and just start to check if there's a pattern. So if I multiply this by this, then this by this, then there's nothing else to do here, right? So I'll deal with that in a second, but for now I have minus e to the x cos x, and because of these, this is going to be positive e to the x sin x. So now we get to here. So because this is a flat line, I'm going to multiply these two together, but don't forget to put the integral sign in front. So I'm going to end up with plus the integral of minus e to the x sin x dx. So you know how, like with integrals, like if this was 2x dx, you know how that's just the same as 2 lots of x dx? You can do the same thing here. So I'm going to just rewrite this. So just like that. So then I'm just going to clean this up a bit, and maybe you'll notice something. So this was our equation, right? So you may have noticed that this and this are the same, right? So what you can do is, if you just add the integral of e to the x sin x dx to both sides, you're going to get 2 lots of the integral here, and that's just going to equal the rest of this. And then we just want one of these, right? Because it tells us to just solve for 1, so we can just divide by 2. So the integral of e to the x sin x dx is just going to equal, I'm just going to simplify it a bit in the process, but hopefully you can see why. And there we go, that's just the final answer. If you don't really like this method, you can just do it using the formula, but it's basically just the same logic, except you're displaying it differently. I would recommend finding more of these questions and practicing them, because once you know how to do one, you can basically just do all of them. So I'm going to move into some harder questions now, just to reinforce that knowledge. Okay, so I have another question here that's starting to get a bit harder. I've done question A here, because it's not really relevant to by parts. So moving on to B, one thing that you should notice is that in part A it tells you to integrate the root 8 minus x. So that generally tells you that in part B they're going to want you to use that result. So that's a good sign to use the root 8 minus x in the integral side, because you have that result already right here. And then I'm just going to put the x minus 2 into the differentiation side. So then if I just differentiate first, this is going to go to 1, and then this is just going to be the result from earlier. And then you are going to have to integrate this again, sadly, but it's not too bad. It's just a reverse chain rule. So this is going to go to 0, and this is going to be 4 over 15, 8 minus x to the power of 5 over 2. So then we're just going to multiply and add everything up. So we're going to end up with minus 2 over 3, 8 minus x to the power of 3 over 2, multiplied by x minus 2. And then we're going to add, but because there's a minus there, it's going to subtract 4 over 15, 8 minus x to the power of 5 over 2. But it says it wants it in this form, right? So what we can do is factor out an 8 minus x to the power of 3 over 2. So then this becomes minus 2 over 3, x minus 2, minus 4 over 15, 8 minus x. I am kind of running out of space here, so I'm just going to do this nice and quickly. So if you expand this middle bracket here, you're just going to end up with minus 2 over 5, x plus 2. And then you can just take out the minus 2 over 5 to the front to get it in the form it asks you for. Minus 2 over 5, 8 minus x, 3 over 2, x plus 2. And then don't forget the plus c. Okay, so this is going to be the last question I'm going to do because it's kind of getting hard to find difficult questions, to be honest. But starting with this, it does look a bit harder, but it's not too bad. So one thing I want you to be aware of is that when you have like more complicated looking functions, like something like this, you should always think about whether it's easier to differentiate or integrate this. So this is actually in the formula book. Ln sec x differentiates to tan x. So if you just think about this, if you put this into the integration side, that would be horrible to integrate, right? So they're not really going to ask a question like that. So just based on like that logic, that's usually what I do, is just think about how mean they would be in an exam. They wouldn't be that mean. So this should go in the differentiation section. You should always be aware of what it would become though, but like you can use that trick. So that means sin x would go into the integration side. So then as I previously mentioned, this would just become tan x, and this is going to become negative cos x. So then this is positive and this is negative. I'm going to stop here because when you multiply tan x by cos x, tan x is just sin x over cos x, right? So the cos x actually just cancels out the cos x here, so you end up with just sine. So if I start by doing minus cos x ln sec x, and then because it's negative times negative, that's just positive. So I'm going to add the integral of tan x times cos x is just sin x dx. So then this just becomes minus cos x ln sec x minus cos x plus c, and then we can just factor out a minus cos x, and that's it. So hopefully with some practice that'll become a bit easier, but just as a recap, when you have d and I, you either stop when the differentiation sides gets to 0, or you stop when you're able to integrate the product of this column and this column, like something like this, or you stop when it's the exact same in like a future row, like the ex sin x example I had, because then you can just use the dividing by 2 trick. So yeah, that's it. Please let me know in the comments if you need help with anything, but yeah, thanks for watching, bye.